All right, so I'm coming back and doing this example all over again using y values this time. Now, let me repeat again. It might be a little easier with y's. It might be a little easier with x's. It's really just kind of up to you. Now, what I want to repeat again is I need to make sure I pay careful attention to what my radius is and what my height is. Okay, so in this case, my radius is, if I were using x's, it's going to be 2 times the square root of x, because that's how far it is from here to here. Now in this case, I'm trying to use y values. So in this case, it's just y. It's however far I went from here to here, which is just y. So again, let me repeat, my radius is going to be y. Now, I'm also going to go ahead and switch my function into terms of y. So right now I've got it as y equals 2 square roots of x. What I'm going to do is divide by 2. So I'm going to write 1/2 of y equals the square root of x. Then I'm going to square it, so I get 1/4 of y squared equals x. Now, I'm going to point out to you, in this case, my height is going to be this function. And so this is where I want to kind of pay attention to what I'm dealing with. So let me repeat again. When I was dealing with x's, the function was my radius. It was also my height. In this case, this is going to be my height, but my radius is just y. So remember, I need to go ahead and write this as f of y. Then I need to take its derivative and square it and do all that other wonderful stuff. So if I go ahead and take 1/4 y squared and I take its derivative, we're going to multiply it by 2, so that's going to make 1/2 instead of 1/4, and I'm going to have just a plain old y. Then I need to remember to go ahead and square it. So when I square it, I'm going to get 1/4 of y squared. Then I'm going to add 1 and take the square root of it. I'm also going to rewrite this just to make my life a little easier as y squared over 4, just because you'll see why in a second. It's going to make my life a little easier when I do the square root part. So 1 plus that thing, f derivative of y squared. So I'm going to write the square root of 1 plus y squared over 4. Remember, good idea here, common denominator, take care of all that stuff. So common denominator, I'm going to have 4 plus y squared over 4. Split it up, 4 plus y squared over the square root of 4, which gives me just a plain old 4 plus y squared over 2. Okay, now all this stuff, get ready to go. We're going to go ahead and start working on my integral. So my integral in this case, I'm not using these x values. I need to plug them into my function to get the y value. So in this case, I'm going to integrate from 2 square roots of 3 to 2 square roots of 8. And the reason I'm doing that, again, I'm plugging these in here. Now, if you wanted to simplify the 2 square roots of 8, that's all fine and dandy. You'd end up with 4 square roots of 2, and that's fine. It'll work out the same way. It doesn't really matter which one you write. Just write it. It'll work out in the end. So I'm going to write 2 times pi times, remember, let me repeat again, my radius in this case is the y value. And I'm going to multiply that by this thing that I found down here, which is 1/2 of the square root of 4 plus y squared. Now, I've got all that taken care of. I'm ready to move on to the next step. So notice 2 and 1/2, they're going to take care of themselves. And everything else is going to take out that pi. Everything else is going to work out kind of nicely. So I'm taking out the pi. I've got 2 square roots of 3, 4 square roots of 2. Y times the square root of 4 plus y squared. Don't forget my dy's. Now, probably a good idea to use u substitution at this point. So u equals 4 plus y squared. I'm going to go ahead and think about plugging in these y values and making my life a little simpler and use them as x's, or use them as u's, excuse me. Let me go ahead and take care of du though. So that's going to end up dropping the 4, and that's going to end up being 2y dy. So in this case, I've already got the y, I've already got the dy, I just need to handle the 2. So I'm going to have 1/2 of du equals y dy. So I need to remember, put that 1/2 up there when I get into it. But don't forget, I'm going to plug in these y values. So y equals 2 square roots of 3 into this 4 plus y squared. So 4 plus 2 square roots of 3 squared ends up giving me a u of 16. So that's going to be my lower bound. I'm going to also use 4 square roots of 2. I'm plugging that in. 4 square roots of 2 squared plus 4 gives me a u of 36. Now, notice these are important, so these are my new upper and lower bounds. So my surface area is pi times 16 to 36 of that integral. I'm switching that y out for a u, so that's going to be 1/2 of the square root of u du. Remember, that's actually u to the 1/2. So that'll be important in a second. I'm going to go ahead and take out that 1/2 and write it as pi over 2. And I'll rewrite, let me say it again, that u is to the 1/2 du. Then I'm going to go ahead and integrate that. I'm going to get u to the 3/2. So I'm going to end up multiplying by 2/3. Don't forget my pi over 2, which in this case, 2's are going to cancel, make my life simple. So I'm going to have pi over 3. And I need to integrate from 16 to 36. So I'm going to have 36 to the 3/2 minus 16 to the 3/2. Now those are not going to be pretty numbers. I know that the 36, the square root of it is 6. So I'm going to end up doing 6 to the 3rd, and I'm going to end up doing 4 to the 3rd, which is not going to be all that much fun. So let me go ahead and do that. So 36 to the 3 over 2 is going to end up being 216. I'm going to go ahead and write that down over here. So I'm going to have pi over 3 times 216. And I want to say that 16 is going to end up being 64 when I get out. Yeah, 64. All right, so 216 minus 64 gives me 152. So I'm going to have pi over 3 times 152, which is, 152 pi over 3. Oh, wait a second. Wasn't that answer the same thing we got when we integrated by x's? Well, isn't that nice? Isn't that wonderful how everything works out so that we get the same answer no matter whether we integrate over x's or y's? So let me repeat one more time. Just an important idea. It doesn't matter whether you integrate over x's and y's. What matters is the way that you write it. The way that you write it. So just important skills for you to think about. Hopefully this helps you get a better understanding of the difference between using x's and y's. Maybe you figured out already that if you're integrating over the x-axis, or excuse me, if you're rotating, you're revolving around the x-axis, your radius is the y. If you're revolving around the y-axis, you can use the radius as x values. Maybe that helps you out. I don't know. We'll see. But let me know if you have any questions, practice problems, use them. Feel free to let me know whatever you need. All right? Have a great day.